the first thing I'm going to do, whenever I see a y prime, I'm going to rewrite that as dy dx so that we have two variables that we can separate from one another. All right. Whenever you have a sum or difference of variables on one side of an equation, what you want to do is move one part of that to the other side so that you can create a proportional relationship. So I'm going to add y times x plus 1 to both sides. All right, so if I can get my y's on the left and the x's on the right, then I'll be in pretty good shape here. In order to do that, it looks like I want to divide both sides by y. So that's really the same as multiplying both sides by 1 over y. Then I want to multiply both sides by dx. And you can do this any way you want. You know, it's just algebra 1 stuff. So dx's would cancel. The y's cancel on the right-hand side. I'm looking at 1 over y dy equals x plus 1 dx. All right, so I don't want dy's and dx's in my answer. I want just y's and x's. So what technique should I use to get rid of the d part of dy and dx? I want these to go away. Antiderivative, yeah. All right, when in doubt, default to the title of the unit. All right. What is the antiderivative of 1 over y? ln of y. And what is the antiderivative of x plus 1? How about just the x? Antiderivative of x. Coffee break. X squared over 2, or 1 half x squared, yeah. Plus x plus c.
Where did the absolute value of y come from?
That's part of the rule.
Oh, okay.
All right, I'm going to rewrite the natural log of y as log base e of the absolute value of y.
Do we not have a c value with our derivative of 1 over y?
You do, but when we bring it over to the other
Yeah,
side,
it's like 1 combined.
exactly. So x squared over 2 plus x plus c. All right, I want to make this, or I want to put it in exponential form. So I'm looking at the absolute y is equal to what? E to the dot, yeah. All right, so I can go further because each one of these pluses or minus in an exponent, allows me to break up my exponential. So I can write this as e to the x squared over 2. I'll just write each part, e to the x and e to the c. What are my connectors? Addition, subtraction, multiplication, division, multiplication. All right. So e to the c is equivalent to what? It's a constant, yeah, so c e to the x squared over 2 times e to the x, that whole thing is equal to the absolute y. But now I can drop the absolute, all right, because of the presence of that constant c. All right, we talked about this. Again, it was a week ago, and there was a vacation mixed in, so it's understandable if you lost it. But absolute y is the same as saying plus or minus y. If I divide both sides by the plus or minus 1, that is the coefficient of y, it's going to get absorbed by the c. All right, so this would just go right to y equals c e to the x squared over 2 times e to the x. Maybe you want to put it back together, because once you have that constant separated out, you really kind of did what you needed to do. So you could write it as c e to the x squared over 2 plus x. Either one of those answers are equally acceptable. All right. Now, if you needed to figure out what the c value was, you'd have to be given an initial condition. You'd have to tell you a coordinate or something like that, where you plug in for x and y and solve for c. That's stuff that you see on page 11, but you need to obviously work up to that.
So we'd solve